In this video, we're going to review some stoichiometry problems. Here's the first problem. We have a synthesis reaction of water from hydrogen and oxygen gases. If you want to produce 57 grams of water, how many grams of oxygen are you going to need? First thing we'll do in this problem is we're going to write out the reaction, then balance it. So the reaction is a synthesis reaction from hydrogen gas and oxygen gas to make water. If you want to practice balancing, you can take a second and balance this yourself. If not, I'm just going to show it to you. For every one of these. And it says we start with 57 grams of water, so let's start with that. It's asking us how many grams of oxygen are we going to need. So we have to convert grams of water. We're going to have to go from mass first. Then we're going to have to convert the grams to moles, and then we'll have to go from moles to grams again to get grams of oxygen. So first I want to get moles of water. So I'm going to put moles on top. Moles of H2O. For every 1 mole of H2O in general, you have about 18 grams of H2O. 16 plus 2. 16 for the oxygen, 2 for the hydrogen. So this is the first step where you convert from mass to moles. We now have moles. So the next thing we're going to do is convert that molar amount to a molar amount of oxygen. So what we have to do is we have to look at these numbers we use to balance. So right now, at this point in time, I have moles of H2O, as you can see here on the top. I have moles of H2O. I have to convert that to moles of oxygen. So I'm going to put moles of O2. I'm going to get rid of moles of H2O. When you look at the reaction, for every 2 moles of H2O, you have 1 mole of oxygen. So at this point in time, I've divided out moles of H2O, and I now have moles of O2. My last step is going from moles of O2 to a mass of O2. So I want mass, and we'll get rid of the moles. For every 1 mole of oxygen, 16 plus 16, that's 32 grams of oxygen. So really all you're doing is 57 times 1 over 18 times 1/2 times 32. And that gives you 50.67 grams of O2. That's how many grams of O2 you will need for this reaction to produce 57 grams of water. Let's do the next problem. So here they talk about a reaction involving hydrazine and dinitrogen tetroxide. And they're saying what mass of water is produced from this reaction. You might not be familiar with this reaction. We take our hydrazine, combine it with the dinitrogen tetroxide. All you're going to get is nitrogen and water. Again, if you want to pause the video, take a second, try to balance this just to practice. That'd be a good idea. If not, here it is. So you can see in stoichiometry how important it is to balance. Based on the last problem, if you don't balance right, then you're going to mess up your ratios and you'll mess up the problem. So we start with kilograms of hydrazine. So first thing I'm going to do before I even start this problem is convert that to grams. Grams of hydrazine. Now I'll do the problem. So in this problem here, I'm given, or they're asking for a mass of water based on the amount of hydrazine we're given. So we're going to start with mass, we're going to end with mass. So it's similar to the last problem we did. So let's write out my amount here. So first thing you want to do is convert the mass to moles of hydrazine. So for every 1 mole of hydrazine, you have 2 nitrogens and 4 oxygens. That's a total of 32 grams of hydrazine. This will cancel out the grams and give me moles. So this goes from mass to moles. Next, I'm going to convert the moles of hydrazine to moles of water. So I'm going to go to moles again, but this time I need to use that ratio. So when you look at your formula, here's hydrazine, here's water. It's a 2 to 4 ratio. I need to get water, so water goes on top. H2O. So for every 4 moles of H2O, I have 2 moles of hydrazine. And now I go from moles to mass. So I now have my moles of H2O. I canceled out hydrazine. So now I need to convert the moles of H2O to a mass of H2O. So I need to get rid of moles of H2O and get a mass of H2O. And that's just 18. So that's just times 2/1 times 18. .26 grams of H2O. That's your final answer.